Hello, viewers. Welcome to a mind-bending journey through space and time. Today, we're diving into a question that's as terrifying as it is fascinating. What if Earth were sucked into a black hole? Strap in, because we're about to explore a scenario that bends the laws of physics as we know them. Imagine, for a moment, that an enormous black hole lurking silently somewhere in our galaxy, suddenly decides to make Earth its next meal. Black holes are regions in space where gravity is so intense that nothing, not even light, can escape once it crosses the boundary known as the event horizon. But what does that mean for us here on our blue planet? At first, as Earth drifts closer to the black hole, we might not notice much. Space is vast, and the pull of gravity increases gradually with distance. However, once we get closer, the effects would become undeniable. Tidal forces, differences in gravitational pull between the side of the Earth facing the black hole and the side facing away, would start stretching the planet. This horrifying process is called spaghettification, and yes, it's exactly as bizarre as it sounds. Earth would be stretched into a long, thin shape like a cosmic noodle. Mountains, oceans, and even the atmosphere would be pulled apart. Time itself would start behaving strangely. According to Einstein's theory of relativity, as you approach a black hole, time slows down relative to observers far away. So, if anyone tried to watch Earth from a safe distance, they'd see events happening in ultra-slow motion. For us on the planet, the universe outside might appear to speed up. Days could feel like minutes, years like seconds, an effect so extreme that it's almost impossible for our minds to comprehend. The next phase would be the most catastrophic, crossing the event horizon. Once past this invisible boundary, escape becomes impossible. All matter, including Earth and everything on it, would inevitably be pulled toward the black hole's core, known as the singularity, a point of infinite density and gravity. Here, the laws of physics break down. Scientists can predict some effects using equations, but the reality is beyond our current understanding. Once Earth crosses the event horizon, the destruction accelerates. The tidal forces stretch and compress the planet to unimaginable extremes. The oceans boil away instantly, the crust fractures, and the atmosphere is ripped into streams of gas. Eventually, every atom of Earth and everything on it would be torn apart and pulled toward the singularity. In a sense, Earth would cease to exist as a planet, reduced to pure matter spiraling into a point of infinite density. But what would this look like from an outside observer's perspective? Interestingly, due to the extreme warping of space-time, Earth would appear to freeze in time at the edge of the black hole, slowly fading as the light struggles to escape its gravitational grip. From afar, it might seem as though our planet is lingering at the threshold forever, even though, for anything falling in, the end is swift and unavoidable. Black holes also produce something called Hawking radiation, a faint glow caused by quantum effects near the event horizon. In theory, this means the death of Earth could create a tiny burst of energy visible to the cosmos, though it would be nothing compared to the planet's destruction. Thinking about this scenario is terrifying, but also highlights the incredible power and mystery of black holes. They're cosmic vacuum cleaners, yes, but they also warp time, bend light, and challenge everything we know about physics. While the chances of Earth ever being swallowed by one are astronomically small, imagining it helps us understand the extremes of our universe and the fragile, precious nature of our home planet. So, Next time you look up at the night sky, remember, somewhere out there, black holes silently wait, reminders of how vast, strange, and awe-inspiring the universe truly is. As Earth drifts ever closer to the black hole, the sky itself begins to warp. Stars stretch into streaks of light, curving around the dark abyss. At first, people might notice odd gravitational quirks, tides behaving strangely, objects weighing more on one side than the other. But soon, chaos would erupt. The oceans surge violently, mountains crack, and the ground itself trembles under the pull of forces beyond imagination. Cities crumble as the surface stretches like taffy. Oceans evaporate into clouds of gas, sucked into the growing whirlpool of gravity. The very atmosphere is torn apart, leaving nothing but a thin, flickering shell of what once was. Time slows. Minutes stretch into hours, hours into years, from the perspective of distant observers. To anyone watching from far away, Earth would appear frozen in place, dangling at the edge of the event horizon, a ghostly planet trapped in a gravitational limbo. Inside the planet itself, the experience would be incomprehensible. People, animals, and even the very molecules of Earth would feel tidal forces stretching them into thin strands. Space-time itself bends, making directions lose meaning. Up and down, forward and backward, all twist into a chaotic swirl. The planet's core collapses first, then the mantle, and finally the crust, until all that remains is a spiraling stream of matter, inexorably drawn into the singularity at the heart of the black hole. And yet, from across the cosmos, the black hole continues its silent feast. Perhaps a flash of Hawking radiation hints at the tremendous energy being absorbed, a faint signal of a planet's end. But to the black hole, Earth is just another droplet in an endless cosmic ocean, a stark reminder of how fragile our world is compared to the vast, indifferent universe. Now, let's step back from the drama and look at the science behind it. The thought experiment of Earth falling into a black hole illustrates some of the most extreme phenomena in our universe. Spaghettification, the stretching of matter due to tidal forces, shows just how powerful gravity can become near singularity. The slowing of time near the event horizon is a vivid demonstration of Einstein's theory of general relativity, revealing that time is not absolute, but can be stretched or compressed depending on gravitational fields. Black holes also highlight the limits of our understanding. The singularity, where density becomes infinite, is a place where our current laws of physics break down. Scientists continue to explore quantum gravity theories to explain what truly happens inside a black hole. Even the small phenomenon of Hawking radiation, a faint quantum glow, hints at deep connections between gravity, quantum mechanics, and information, a puzzle that keeps physicists awake at night. So why imagine such a catastrophic event? Because it allows us to confront the extremes of nature and appreciate our planet's fragility. Earth is delicately balanced in the habitable zone of the Sun, protected from such cosmic threats. While the chances of a black hole swallowing us are astronomically small, exploring this scenario expands our imagination, deepens our understanding of physics, and reminds us how precious our home really is. In the end, thinking about Earth being devoured by a black hole is terrifying, but also awe-inspiring. It's a glimpse into the incredible, mysterious, and sometimes unforgiving universe we live in, and a reminder that the cosmos is far stranger than we can ever truly comprehend.